Eh, Hola, Ale,
Hola, prof.
¿cómo estás?
Muy bien, ¿y tú?
Muy bien, está bien. A ver, déjame- a ver, pues si quieres de una hora, yo creo que en una hora sí alcanzamos a ver todo lo de súper bien, pues, lo de
Ok,
Crunch.
sí.
Así que va, déjame nomás me uno con el iPad para poder dar. Déjame ver, agarro también algunos ejercicios y así. Lados.
Ok, sí.
¿Qué más? Ok, con este, ok, ya. No, me uno con el Zoom. Ok, bueno. No sé, ¿cómo quieres que te la dé en inglés, en español?
En inglés.
Ok, va, perfecto. Okay, perfect. Then, okay, I think that it's better, yes, because that way your exam is going to be in English. So, what might be calculation? Calculator. Okay. 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 Can you see my screen?
Yes.
Okay, perfect. Well, basically, in like in this partial, right? Well, not this partial, but for this quiz, basically, it was like the projectile motion, right?
Mhm.
Or before doing that, maybe I don't know, like, did you cover free fall before? I don't know, like in the yes, like in the beginning of your semester in your other high school.
Yes.
Okay, well, yeah, basically, if you remember free fall, basically, well, just really fast. Remember that we always are going to have G, right? That
Mhm.
basically is the acceleration of the gravity, right? And it's always pointing downwards, right?
Yes.
And always remember that this one is like the acceleration, it's constant, right? That means that
Mhm.
always we are going to have that acceleration going down. Okay,
Okay.
that's good. It says here the magnitude of this acceleration is 9.81 meters per second squared. Well, negative because remember, like in the train, right? Like in mathematics,
Mhm.
okay, in mathematics we have x, y. Remember that we are going to have positive, right? When we are talking
Yes.
about forward,
Mhm.
and when we are talking, well, and y, positive when we are talking about upward, right? Okay.
Mhm.
Remember y is negative when we are talking downward. And remember that x is negative when we are talking backward, right? Okay.
Yes.
That's really important because if you see like the theory, and they are going
Mhm.
to ask you like the velocity is going down, like of an object is going down. So you know like the y component is going to be negative, right?
Okay. Yes.
Okay. Okay. It says free fall is a motion with constant acceleration. The speed increases at a constant rate with respect to time, right? Okay.
Mhm.
Just go. Okay. Speed and time. Well, okay. For example, if you remember when we have like if you remember like acceleration, the definition is delta v over delta t. And if you remember delta v is the rate of change, right? V2 minus V1, T2 minus T1. That in physics, generally they put it like final velocity, right? Minus initial velocity, right?
Mhm.
And final time minus initial time, right? Basically, that
Mhm.
this one, like the rate of change, right? This one
Yes.
is the acceleration, and you know that the acceleration is constant because we have that the rate of change is always going to be the same, right? Like
Yes.
in this plot. Okay,
Mhm.
perfect. Let's go. Okay. Remember that when we are talking about, okay, vertical launch, right? That if we send something upwards, right,
Mhm.
we are going to have an initial velocity, right?
Yes.
What sign is that initial velocity?
Positive.
Positive, right? In the
Yes.
y direction, it's going to be positive, right? Perfect. Then, okay, good. And remember that this one is going to be affected always by, let me see, by G, right? By the gravity, that this one
Yes.
is negative. So
Mhm.
basically, remember that G is an acceleration, and if it is negative, this means that it will reduce, well, it will diminish, right? V0y. Okay, so for example, if we have V0y, like 50 meters per second, right?
Yes.
Positive. because it's going up. This one
Mhm.
is going to be affected. Every second, you are going to decrease 9.81 meters per second, right? Every second.
Yes.
Okay. And if you continue doing that, there will be a point where this b, y, final velocity in y is going to be 0, right?
Yes.
Meters per second. And that's always going to be when it's at its maximum height, right?
Yes.
Because instantly after that, the ball will start like falling down, right?
Yes.
Okay, so remember BFY, like BFY at its maximum height, it's always going to be 0 meters per second. Okay, perfect. Okay, well, the speed is 0, what I told you.
Mhm.
Okay, displacement. Okay, yeah. Well, these formulas are
Mhm.
the ones that we are going to use a lot in vertical launch, right?
Mhm.
Well, yes, when we're talking about y in the projectile later, okay. This means BF, it means final velocity, right?
Mhm.
Okay, VI, it means initial velocity. Okay, A, it means acceleration. X, it means, okay, distance, right? Uh,
Mhm.
well, yeah, because this one can be Y or can be, it depends. Like when we're talking about projectile, this is going to be Y, but okay. It's going to
Mhm.
be Y, it's going to be H, our height, right? It's going to be G, like that. Well, yeah, like this one. I didn't say it, but basically this ones. Okay, when we're talking about vertical, okay, well, let's see. Okay. Well, maybe better projectile. Okay, here we have arrived to launching from projectile, right? Okay.
Mhm.
That's the important because that's the one that we are going to cover in this exam. And well, basically, the only difference when we are talking about projectile, right, is that in this time, our velocity, right, is going to have two components.
Okay.
Going to have the component x, right?
Yes.
And it's going to have the component y, right?
Yes.
Okay, basically, like if you remember, for getting the components of any vector, we can, for example, for getting the x component of any vector, remember, okay, this one is going to have an angle, right?
Mhm.
Okay, we take the magnitude, well, of any vector, like first of any vector. This, like these symbols, like the two lines, right?
Mhm.
It means magnitude of a vector. Okay.
Yes.
Okay. And what does it means magnitude of a vector? Okay. The magnitude is really related to the Pythagoras theorem. If you remember
Mhm.
from Pythagoras, from geometry, we have, okay, we have, this one is our C, that is our hypotenuse, right?
Yes.
Okay, we have this, that is our A, that basically is to this angle, this is the adjacent angle, well, adjacent side, sorry, adjacent side. And B, right, is our opposite side.
Yes.
Okay, the magnitude basically is just applying the Pythagoras theorem, that if you remember, it was C squared, A squared plus B squared, and basically C, to getting the value of the hypotenuse, we have to do this formula, right?
Yes.
Okay, for the vectors, it's kind of the same. For getting the magnitude of a vector, because if you remember, a vector basically is just an arrow, right? That it
Yes.
has a magnitude and a direction that basically is an angle, right? This is the magnitude, and this is the angle, right? The direction. Okay, so basically we represent in the vectors the magnitude as the length of the vector, and the angle is the direction, right?
Yes.
Okay, this is important because, okay, this means that the magnitude is going to be the two components, right? Basically, this one, this part is the x component, right?
Yes.
And this part is the y component. So if we translate like the formula, we see that we're going to have bx squared, right? Plus by squared, right? And the square root of that. Basically, just applying the Pythagoras, right? In physics, right? If you see
Yes.
like the equivalencies, A is equivalent to Bx, By is equivalent to B. That's why we have this formula. And this is, remember, the magnitude. Okay. Then that's for the magnitude. But if we want to take now the components, if we have opposite, like we have the magnitude, and we want to get the components, we apply the property, if you remember, cosine of the angle.
Yes.
Because if you remember, like really quick, okay, let me put it. Okay. Cosine, right, of the angle, the definition is adjacent side, right, over hypotenuse. So if we want to get the adjacent side, that as we see here is the x component, right? We
Yes.
have to do the algebra, and we just have to get the adjacent, we multiply the cosine of the angle times the hypotenuse. And in this case, the hypotenuse, we said that it was the magnitude of the vector, right? So
Yes.
basically, for getting the x component, we do this. That's why, let me see. We get the magnitude times the cosine of the angle for getting bx, right?
Yes.
And for getting by, it's going to be almost the same, but this time is the magnitude times the sine of the angle, right?
Yes.
Okay, basically, these two are really important because, okay, always, like when we are going to talk about projectile launch, right? We are going to take, because projectile launch, let me see. Okay, wait. Projectile launch, also, it's called like parabolic, right? Launch. That basically these two are two dimensions, 2D, or well, two dimensions movement. Why? Because the two dimension, it means that we are going to analyze this system in the x dimension and in the y, right? In x and y coordinates.
Yes.
That's why it's called two dimensions, and it's also called parabolic because the figure, right, is going to be basically a parabola, right?
Yes.
Okay, perfect. Okay, it says a projectile shot is moving in two dimensions, right? As we said, it flies in air both vertically, right? You remember that vertically it's equal to y, right? And horizontally it's equivalent to x.
Yes.
Okay. And it's only under the influence of gravity. Perfect. Okay. Okay. Yes, as it says here, one of the easiest ways to understand this movement is to analyze each dimension separately, right? So that's why we are going to have formulas for y, right? And formulas for x, because they are two different type of movements also. Y is a one with constant acceleration. And this one is one with constant velocity. So in here, let me put it, there's going to be a change in velocity because it has an acceleration. And this, as it says that it's constant, okay, let me put it. There's no change in velocity because we said that this one has a constant velocity, right? So in X, our velocity horizontally is always going to be the same. So basically, Vx is always going to be equal to the original velocity in X, right? This is always going to apply for projectile movement. Okay. Gravity will only affect, okay, vertical velocity. This means that because if you remember, the G always points downwards. So basically, this one, it just affects to the Y movement, right?
Yes.
Okay. Then let's continue. Okay, basically they like two type of problems, right? That is basically the horizontally and the vertically. The horizontally basically is like if you are in a risk, like I don't know if you remember that I put like you are like this, a person, right? And you kick this ball, right? And it has only velocity in X, right?
Yes.
So if you do that, like, okay, you are going to have that your original velocity in X, right? It's some value, but that your original velocity in Y is going to be equal to
0.
0, perfect. Why? Because you don't have a component in Y. And also, well, if you want to make it like mathematically, you remember B0Y is equal to sine of the angle times the B0. Okay, if our B0 is something like, I don't know, let's say 10 meters per second. But the angle in here, what's the angle in here if it is horizontally?
0.
0, right? So if you remember from trigonometry, the sine of 0 is equal to 0.
0.
So 0 times anything is going to be 0.
0.
That's why in horizontal launch, or when it says like you kick a ball horizontally from a height, whatever, when it says horizontally, the B0Y is going to be the original, right? The original.
Yes.
But it's going to change the velocity because we always have the gravity, right?
Yes.
So basically, yes, there will be a big Y final, like a BFY, right? Final. But that's thanks to the gravity. Okay.
Okay.
The horizontally in the parabolic is when you have, okay, maybe. Okay. The parabolic one is when you have both, right? When you have horizontally and when you have vertically velocities, right? Original velocities.
Yes.
So y, b0x, right? And then basically this will have like a parabola shape, right?
Yes.
In this point, it's its maximum height. That basically, this is where we are at our vertex. If you remember from mathematics, the vertex, right? Basically, if you remember, it's half of the parabola, right? In the
Yes.
vertex, we are at the half of the parabola. Okay, that's something really important. Later, we are going to see why, but okay. This says two types of movements are involved. URM, that is uniform rectilinear movement. Yeah, well, that's like a definition, like in both. Uniform recti, okay. Movement, right? Okay. And the other one is, well, this basically means that the velocity is constant, right? Bx is constant. And the other one, the uniform acceleration recti movement, right? It means that the object has an acceleration, that our acceleration is g, basically.
Okay.
Or everything, okay, velocity has two components, horizontal, okay, and vertical, yeah, we said that it has these two. Okay. Wait, let me see. Well, yeah. Let me see like if the formulas, if I have the formula. Okay, well, these are like the important. Maybe basically, okay. Mhm. Okay, well, basically, we are going to have these formulas.
Okay.
These formulas, this horizontal are for X, and these vertical are for Y, right?
Okay.
Okay.
Yes.
Also, we have one that is not included here, but I'm going to put it here. Velocity final, Y, plus velocity, inner velocity times time, right?
Yes.
Okay, we are going to use these formulas for analyzing this. Something well also really important, like maybe before doing this, like the concepts. For example, let me put it. Reach, also called range. In Spanish, alcance, right? This is the movement, well, the distance in X, right?
Okay.
Okay. Something also really important is the H max, that basically means the maximum height, right?
Yes.
The maximum height basically is the maximum possible y distance, right? Like the maximum that it can take our parabola. Basically, the top of the parabola that is our vertex, right?
Yes.
Okay, what else? Okay, if you remember, what's the, okay, at H max, right? At H max, right? What's the, okay, let's put it in another color. Okay, what's our velocity in Y when we are at our maximum height?
0.
0, perfect. And well, for example, if we had V0x equals to 10 meters per second, what value are we going to have for VFX?
5.
What?
5.
No, 10.
Ah,
Because
okay.
if you remember, Vx is always going to be constant, right?
Yes.
Our velocity in X, it will never change. So if your original velocity was 10 meters per second, in all your trajectory in the X direction, your velocity is always going to be constant. That's something really important because even in the exam, like later we are going to see it like in 10 minutes, but they ask you like in one question, what's the velocity in the top of the, like the horizontal velocity in the top of the parabolic movement, right? They ask you that in order for you to confuse because you said, oh, it's 0 because it's for Y, but that's for Y. But for X, it's always going to be constant, right?
Yes.
So it's
Okay.
always going to be the same value. It's going to be, for example, for this one, it's going to be 10. Okay, well, something also really important, like in concepts, is like, that's why, for example, when you have like a gun, right? You have a gun, right? Okay, and you shoot to the sky. That's why it's really dangerous if you know, like the lost bullets, right?
Yes.
The lost bullets are really dangerous because with the same velocity that you go down up, it's going to be exactly the same velocity that this bullet is going to, well, this velocity, right? The original one is going to be exactly the same when it falls down at the same height, right?
Yes.
Okay, that's something really important. So, for example, you can really easy know if they ask you, okay, for example, if I shot a bullet, right? I don't know, I don't know, like at 100 meters per second, right? an angle, I don't know, let's say of 30, right?
Yes.
Degrees. Okay. If you do that, what's going to be the magnitude when the bullet goes back? It's also going to be 100 meters per second, right? Because
Yes.
it's going to be exactly the same magnitude of velocity. The only thing that is going to change is the direction, because now it's going to go down in the y, right?
Yes.
Because it's falling down. But basically the magnitude is the same. That's why the lost bullets are really dangerous.
Yes.
Okay, this formula, the V, well, this one, X, B, I, X time. This time is also called, like this time of flight, right? Basically, is the time that an object is in the air, right?
Yes.
Okay, basically this means, yes, is the time that the object is in the air. And this one is really important because this is the one, well, this affects the complete movement because, okay, for example, something that is also from theory is, okay, which angle, right? Which angle do you think that is going to give you the maximum, sorry, the maximum possible height? Well, the maximum height, right? Which one
Yes.
is going to give you like the best maximum height?
45.
No, well, that's for the best reach. Like for the best reach, yes, it's 45. But for maximum height, it's just like shooting or like up, right? Like
Yes.
this is going to be 90
No.
degrees for getting the maximum height, because well, it's like logical. If you shoot something up, right, obviously it's going to travel more distance up, right?
Yes.
So basically you're going to get the best possible maximum height. For getting the best reach, right, that basically that's the X distance, right? The best is to show it at 45, because at 45 is like in between of X and Y, right? It's like in the between. And doing that, if you see like the formula that it was, okay, X, B, I, X times, right?
Yes.
If you do that, the 45 is going to increase, well, it's going to maximize the velocity in Y. But the component Y is the one that affects the time of flight, right?
Yes.
So basically, 45 gets you the best of both, like maximizes both. And if you maximize both in a multiplication, you are going to get the best possible value, right? And in this case, as we are talking about the range, basically, the best possible angle is 45, right?
Okay. Yes.
Okay, perfect. Then, okay, we have here the exam, right? That we answer, well, the other version, because okay, let's go forward. Okay. Then, okay,
Prof, the formulas are gonna come in the exam.
yes. Like,
Okay.
yeah, I'm going to give you, like, I don't know if you can see it. I don't have like a digital version because they just gave it this one to me, but I will give you like this physical,
Okay.
right? Okay.
Mhm.
Well, basically, yeah, you're going to have like, okay, maybe let me, okay, I don't have enough light. Okay, maybe I will, okay, wait me a minute.
Yes.
I'm going to take a picture of this and I'm going to put it like in the iPad. Yeah,
Okay.
let me see. That's enough light. Yes. Okay. No, I don't know why it's not.
I'm sorry, I have to answer really fast.
Yeah.
Yeah, sorry.
Okay. Perfect. I just have it. Let me share it with you again.
Mhm.
Okay. Okay, well, basically these are going to be like your formulas, right? That you're going
Yes.
to have in your exam. Maybe let's do some exercises. I'm going to give you a different exam, so yeah, you can basically do this one. Like
Mhm.
the one that we did in class. But okay, let's do it. Okay, good. It says in parabolic launch, the vertical velocity is 0 meters per second, right? Okay, let's do it together,
Yes.
maybe. Okay, what do you think?
Yes, 0, true.
True, right? Perfect. It's true because if you remember, when we are like in the parabola, right? At this maximum point, the maximum height, right? We are always going to have that the BFY is going to be 0.0,
Yes.
right? Perfect. Okay, next one. The time that it takes to reach the maximum height in parabolic launch is half of the total time. If you remember, we said that this was the vertex, right? And that the vertex is always in the middle of the parabola.
Yes.
So basically, what do you think in this one?
True.
True? Perfect. Okay, next one. The horizontal velocity in parabolic launch has an acceleration of minus 9.81.
False.
False, right? Because it says horizontal velocity, right?
Yes.
So basically, this is going to be false because this will be just correct if we have vertical, right?
Yes.
But as we have horizontal, yeah, it's false. Okay. When an object is thrown diagonally, remember that diagonally means like the diagonal, right? The vertical velocity never changes. What do you think?
False.
False, perfect. Because it says vertical velocity. Remember that the vertical velocity is the one that changes.
Yes.
The one that is constant that never changes is the horizontal, right? Or the
Yes.
Bx, right? Bx is the one that is constant.
Mhm.
Perfect. Okay. Continue. Let's continue. The vertical velocity is negative when an object is moving downward.
True.
True, right? Because if you remember from mathematics, we were saying that, remember that y positive up, y negative down, right?
Yes.
So for vertical velocity, yes, this will be true. Well, okay, let's continue. It says, during the trajectory of a parabolic launch, right? The horizontal velocity, okay, let's read them. What do you think? A, it says change its magnitude and direction. We are talking about horizontal velocity. Does it change its
Yes.
magnitude?
No.
No, so this one cannot be. Okay, letter B, changes its magnitude but maintains its direction. The horizontal
No.
velocity.
No.
No, perfect. Okay, letter C, changes its direction but maintains its magnitude.
No.
No, because if you remember, if you send something like in this direction, it will always go forward, right? It will not
Yes.
change its direction. It will not go backward like suddenly. No, it will not do that. It will always maintain its direction. So this means that the only possible one is says maintains the same direction and magnitude, right? So this is
Yes.
letter D.
Okay.
Perfect. Okay, number 2. It says, the following drawing shows the trajectory of a toy cannonball. At which point will the horizontal velocity be 0 meters per second? Okay.
7. D.
D, right? Never. Why?
No. T. No, horizontal, yes, D.
D. It's never because remember that we have, right, an original velocity in x. And if this is constant, right,
Yes.
this will never going to be 0. Like in any point, we will have the same bx. So basically, this will never be 0. That's why it says never, right?
Yes.
Okay, perfect. Let's continue. Okay. A football is thrown in parabolic launch, right?
Mm-hmm.
What is the vertical velocity at the maximum height? What do you think?
0.
Perfect. It's 0, right? Because we said that at the top of the parabola, at the vertex, right? The velocity is going to be 0. Perfect. 4. In parabolic launch, we can state that. What do you think in that one? Okay, let's read them. A. Acceleration changes in the first half of the path. What do you think? In the
No.
second path? Yes, perfect. No, because, yeah. Okay, first of all, the acceleration doesn't change, right?
Mm-hmm.
Okay. Letter B. The horizontal velocity is constant.
Yes.
Yes, perfect. So this will be B, right? Perfect. Sorry, I don't know why it moved. Okay. 5. Let's read the 5. It says, when an object is thrown forward, right? Basically, forward.
Mm-hmm.
I don't know why it's like this, right? When
Yes.
an object is thrown forward with a horizontal velocity, right? So the horizontal velocity, right? Of 24 meters per second from the roof of a building, right? Imagine like you have, okay, like this from the roof of a building, right?
Yes.
What can we say about its vertical velocity and horizontal velocity? Okay, let's read them. Its letter A. Its vertical velocity and horizontal velocity are both positive. Okay,
No.
first of all, Bx, what sign do you think that it has? If it's
Positive.
positive, right?
Yes.
And By, which sign?
Negative.
Negative. Perfect. So we can, well, we can say this one, no, but we can skip and say this one. It says its vertical velocity is negative. Remember that this is vertical, right? Y, vertical, and X is horizontal, right?
Yes.
So basically will be letter. What do you think? Which letter?
C.
See? Yes, yeah. Letter C, right?
Yes.
Okay, its vertical velocity is negative, right? But its horizontal velocity is positive, right? Perfect. Okay, great. Let's continue with the problems, right?
Yes.
Okay. In here, let's take this one. Yes. Wait. Mm, mm, mm. Okay. Right? Okay. We have the formulas in here, right?
Yes.
Okay. First of all, let's see the problem. Well, like what I told you, like your classmates, like if I have to put like steps for doing a problem of this type, right?
Mm-hmm.
Basically, something that is really useful is to always get Vix and Viy, right? The original velocities, the components of these ones. Also is
Yes.
something really useful. Number two, it's to get the, okay, what are they asking you, right? Okay, they are asking you, for example, total time and range. Well, in the problem it says, a sphere is thrown at 15 meters per second horizontally from the roof, right? 65 meters building. How long will it take to reach the ground? And, well, how long? Basically, this is the time, right? Total time. And what is the range? Is this one, right?
Yes. Range was the
Reach.
average. Yes.
Also, it is the x maximum, right? The x distance.
Yes.
Okay. In the parabola, let me put it in the parabola, right? Okay. Basically, the reach, the range is this distance, right?
Yes.
Okay. So basically, that's the range, right? And what are they asking you? Okay. Well, no, sorry. Step number 2 is what they are asking you. Step 3, it will be what data do you have, right?
Yes.
Okay. Number 4 is like look for an equation, right? That has both, like has 2 and 3. This means that it has what they are asking you and what data do you have. But remember that you can just have one unknown, right?
Yes.
Because remember in mathematics, they tell you like you for every equation, right? You need one unknown. Because if not, you cannot solve that equation.
Yes.
Okay. So basically we have this and okay. So, okay, that's like the steps for solving any problem of this type. Now let's apply it to this problem. Okay. It says, a sphere is thrown 50 meters per second horizontally. Okay. A sphere is thrown 50 meters horizontally, right?
Yes.
From the roof at 65, or well, from a 65 meters building, right?
Yes.
So basically, what is this, the 50 meters per second horizontally?
The velocity,
Well,
horizontal.
horizontal, the Vx, right?
Yes.
Is 50 meters per second. Now, what's the value of Vy? Well, original velocity in Y, sorry, the original velocity.
0.
In Y, perfect, it's 0, right? Because it's horizontal. And also, like if you do it like mathematically, it's because the sign of 0, because our angle is 0 when we are talking about horizontal, right?
Yes.
Is going to be 0. Okay, perfect. We have that. Let me okay, perfect. And okay, that's Vx, Vy. Okay. We also have, what is this value? A 65 meters building.
The height.
The height, perfect. So basically this is height 65 meters, right?
Yes.
Okay, so basically we have, okay, that was like the first part, that it was getting the I, well, Vx and Vy, right? Number 2, what are they asking you? They are asking us for what?
Time and range.
Time and range, perfect. And number 3, what data do you have? Okay, we saw that we have, well, we could get Vx, Vy, and we also can get the age, right?
Yes.
Okay, so now number 4, like look for, like in the equation that you have, let's see which ones can we use. Okay, we have, for example, in this part, let's see like this part, right?
Mhm.
Okay, we have, for example, okay, first of all, let's try to solve total time, the time. So let's look for the equation that have time. Okay, okay. This one doesn't have time, so no. This one has time, yes.
Yes.
This one doesn't have time, no. This one has time, yes.
Mhm.
Okay, this one has time, yes.
Yes.
Okay, so we have to look in 1, 2, or 3. But now also we have to see what values do we have, like what data, right?
Yes.
Okay, we said that we don't have the, okay, let me put it in red. We don't have the final velocity in y.
No.
No. We have the initial velocity in y, right?
Yes.
We always have the g, right?
Yes.
Do we have the time?
No.
No. So this one has two unknowns, right?
Mhm.
One equation, so basically we cannot use
Use.
this one, right? Because we need just one unknown.
Yes.
Okay, let's go with the next one. Okay, do we have the height?
Yes.
Yes. Do we have the original velocity in y?
Yes.
Perfect. Do we have the g?
Yes.
Yes. The only one that we don't have is the t, right?
Mhm.
Okay, so basically one unknown, one equation. So basically we can use this one, right?
Yes.
Okay, just for you to see. The next one, we cannot also use it because we don't have the final velocity and the time. So it's going to be two unknowns. So basically the one that we're going to use is this purple one, right?
Yes.
Okay, so basically h equals VIY time plus 1/2 of GT squared. Okay, let's replace the values. Okay, well, I will do it here and later I will make it smaller, but okay. Okay, let's replace the values. The value of the height, what was it?
65.
65, right? Okay. VIY, what do we say that it was?
0.
0, right? 0 times time, right? Plus 1/2 of G. Well, G, it was minus 9.81, right?
Yes.
T squared. Okay. Well, 0 times time, this is going to be equal to 0, right?
Yes.
So basically in here, we are just going to do algebra. The 65 equal to 1/2 of minus 9.81. If you do it in your calculator, right, is 4.905 t squared, right?
Yes.
Okay, and now we just have to do algebra. We pass dividing right there. Well, this one, in fact, the height is negative because if we start from 0, right, if this is our 0, if when we fall, right, when we fall back, this distance is negative, right?
Yes.
So it's going to be minus 65 divided by minus 4.905, right? And if you remember from mathematics, when we have something squared, right? How do we pass it to the other side?
With the square root.
The square root, perfect, right? So basically we're going to do the square root of that. Okay, can you tell me, like, do you have your calculator with you?
Yes. What I did first, is it wrong if I first take out the square root of -4.905 and then the answer
Yes.
that divided?
Yes, it's wrong
Okay.
because if you remember from mathematics, right? What's the order of operations? The first one, like the most important one, is the parentheses, right?
Yes.
Then is the power and the square roots. Well, the squares, yeah, like roots, yeah, like cubic, square, whatever, no? Okay,
Yes.
this is like the first one. This is the second one. The third one is multiplication and division, right? And number
Yes.
4 is addition and subtraction, right?
Yes.
And well, last one, if you remember, is from left to right, right?
Yes.
That's for operations. But for despejes, no, like for solving, it's the opposite way. This is the last one, right?
Okay.
Okay, this is important because, okay, if you see these two, well, these are multiplying, right?
Yes.
Okay, well, this is multiplying to this one. So in order to get this one, we first do the multiplication and then we do the square roots or the powers, right?
Yes.
Basically, first we have to pass this one dividing and then we can do the square root.
Okay.
That's why, because like for solving, it's the opposite way. So yes, like you first have to divide and then the square root.
Okay. Okay. Let me do it. It gave me 3.64 seconds.
Okay, 3.64, right? Seconds.
Yes.
Perfect. Okay. Let me try to make this one smaller. Wait. Mm. Okay, that's good. Now let's do, we have one value, now we have to go for the range. How did you imagine that you can solve for the range? Where do you see the range? Basically, well, first of all, why is the range?
It's the distance in x.
The distance in x, right?
Yes.
So we have to look, remember, like in here, what are they asking you, the distance of x? Okay, so let's look equation that have the distance of x. The only one that I see that it has distance of x is this one, right?
Yes.
Like if you see there is no like distance of x in any of the other equations. So basically it's that one. Okay, so we are going to use that one. Let's see. Do we have the velocity in x?
Yes.
Yes, right? Do we have the time? We just got it, right?
Yes.
So basically we are just going to do algebra, right? Despejar, right? And we are going to get that dx is bx multiplied by delta time, right? So basically we are just going to multiply 15 times the time that we just got, 3.64, right?
Yes.
So what do you have? What do you get if you do that?
54.6.
Okay, perfect. This is going to be...
And it's in meters, right?
Yes, exactly. It
Okay.
is in meters because we are talking about distance, right? We are talking about range.
Yes.
Okay, perfect. Let me just... Okay. For this new one... Okay. Okay, well, good. Okay, now let's do number 2, right?
Yes.
Okay, it says, a stone is thrown horizontally, right?
Yes.
From the roof of a 45 meters building and reaches a range of 70 meters, right?
Yes.
How long will it take? Do you remember how long basically the time, right? Will it take to reach the ground? That basically that's the total time. And what is the horizontal velocity, right?
Yes.
Okay, well, basically, in this one, let's like do the steps that I showed you. Here, let me just copy and paste. Mhm. Okay, the steps, right?
Mhm.
Okay. It says, let me see. Okay. Does it look better like that or?
Yes, it's better. Thank you.
Okay. Let me just move this one a little bit. Oh, okay. Oh, yeah. Okay. It says a stone is thrown horizontally, right? From the roof, 45 meters. Okay. First of all, what is this? The 45 meters building.
The height.
Height, perfect. The height is 45 meters, right?
Mhm.
Well, in here, basically it says the range, right? It's
Mhm.
70 meters, right? Okay, right? Okay. If we try to do like the first step, the VIX, we don't know them. We don't know it, right?
No.
That's why it's asking you why the horizontal velocity, so we cannot get this one.
Mhm.
But can we get the VIY?
Mm,
What do you think?
yes.
Yes, perfect. Because here says horizontally. Basically, what's going to be our angle?
0.
0, right? And if you
Yes.
remember the sign of 0 is going to give us,
0.
so basically this is going to be
0.
0, right? Meters per second. Okay, perfect. Now, let's look like the steps. Okay, what are they asking you? They're asking you, okay, first the total time. So let's go and see the formulas that have total time. Remember that the total time, it depends just of y, right? It depends just of y.
Yes.
That's why we are going to look in the y section. Okay,
Okay.
let's look for the one that has total time. This one has total time. This one has total time, and this one has time, right?
Yes.
These three. Basically, you're going to see that this really close to the last problem, right? It was
Mhm.
almost, it's going to be almost exactly the same for the total time. Why? Because, same again, we don't have this value and we don't have this value. We have two unknowns, so we cannot use that one, right?
Yes.
Also in the last one, we don't have the final and also the time, so we cannot use this one. But in here we have the initial, the height, the G. The only one that we don't have is the time. So it's one unknown, one equation. So basically we are going to use this one.
Yes.
Okay, H, right? It
Yes.
says
45.
45. Yes, perfect. Let's replace it. 45 meters, right? Equals to VIY. VIY, what we said that it was?
0.
0 times time is going to be 0, right? Okay,
Mhm.
cos 1/2 of G, right?
Yes.
Well, remember that this is negative, right? Because we were talking that we started from 0, right? And when we fall,
Yes.
like this distance is negative. Okay, so basically, kind of the same, we are going to divide 45 divided minus 4.905, right? And this we are going to get the square root,
Mm,
right?
yes.
Okay, basically we do that. And what do we get?
It's 3.029 seconds.
Let me check. Check. 3 point what?
0.29.
Okay, perfect. 3.029, right? Seconds, right?
Yes.
Perfect. Now let's go for the horizontal velocity.
Okay.
Now let's look. Horizontal, it means that we are going to use this part, right?
Yes.
of the equation. Where do we have, okay, we have the velocity right here. And we just
Yes.
got the time. So basically
Yes.
forgetting the value that they are, well, sorry, no, we don't have the velocity, right? It's the one that we are going to get. But we just got, well, they give us the 70 meters, right? Basically this one, right?
Yes.
And we just got the time, right? That is 3.029. So for getting the Vx is really easy, just making the division, right?
Yes.
We are going to divide what between what?
70 divided by 3.029.
Perfect. What do you get if you do that?
23.110
Perfect. 23.110 what?
meters.
Horizontal velocity. What the
Meters per second.
meters per second? Perfect. Now, okay, we just solved number 2. Really good. Let's go with number 3, right?
Yes.
The last one. Okay, it says a football player. Okay, let me. Okay, wait, let me go. Okay, it says a football player throws the ball at 20 meters per second at an angle of 55 degrees, right?
Yes.
What is the range and what is the maximum height? Okay, they are asking us basically the range and maximum height. First of all, I told you like it's really useful to get always the components VIX and VIY, right?
Yes.
Okay. VIX, basically, we said that it was cosine of the angle times the magnitude, right? Okay,
Yes.
give me this one is going to be the cosine of what?
Of 55.
55, perfect, right? And times the velocity. What's the value of the velocity?
20.
20 meters per second, perfect, right? Okay,
Yes.
okay. Later we calculate how for y. For y, what is the formula?
Sin times the angle. No, sin of the angle times the velocity
Right? So basically, we are going to get the sin of what?
of 55.
55, right? Times what?
20.
20. Perfect. Okay, now we get both. Let me just move it to the list. It's not there. Okay, let's do it. Can you do it, please, in your calculator, the first one?
Yes, I got 11.472 meters per second.
11.47, right?
Yes.
Second, and the second one, did you do it? What can you
Yes. 16.38 meters per second.
Perfect. 16.38 meters per second, right?
Yes.
Okay, that's really good. Okay, then, okay, let's see. The maximum height or the range. Can we get the range directly? Okay, the range, if you remember, is this one, right?
Yes.
Okay, but
No, we cannot.
we cannot because we have two unknowns, right?
Yes.
We don't know the range and we don't know the time, so we cannot use this one yet. Okay, so maybe let's go with the maximum height, right?
Yes.
Okay, the maximum height, if you remember, right? That's why it's really important, like the definition, the concept. How do you imagine that you can get the maximum height?
With the third formula?
Yes.
No,
for
no, no.
example. Yeah,
Yes.
no, yeah, you can use that one. Also, you can use which one? The other one was it? For example, you can use any of these two, like the one that you said, that like the third formula, right?
Mhm.
Also, you can use this one.
Yes.
Okay. Why? Because, okay, let's see. Okay. Then, if you remember, right? Then, okay, we don't have the height. But do we have the final velocity in Y?
Yes.
What is the final velocity when it's at its maximum height?
0.
Perfect. We have this one. Do we have the original velocity?
Yes.
We just calculate. Yes. Okay. Right?
Yes.
Okay. Wait. Mhm. Well, yeah, but okay, wait. Okay, wait. Okay, no, well, we cannot use those yet, right? Sorry, I make a mistake, right? We cannot use this one yet, right? Because we will have two unknowns. But
Yes.
we can use, for example, it was this one, the one that I tried to say. Yeah. This one, because we have the final velocity in Y that is equal to 0, right?
0.
The initial velocity that we just calculated, that is this one, right? And we always have G.
Yes.
Okay. Basically, we can like substitute, right? The final velocity in Y is equal to 0, right?
0.
Okay.
Yes.
The initial velocity in Y we just calculated, that is 16.38, right?
Yes.
Per second. Plus G. G is minus 9.81 meters per second squared, right? Times T. So basically, we do the algebra and we pass minus 16.38, right? Divided by minus 9.81, right? And we get, what do we get? You have your calculator with you?
Yes. It's 1.67.
Perfect. We have 1.67 seconds, right?
Yes.
Okay. Perfect. That's the time at when we are at our maximum height, right? Okay. Now we have the time. Now, yes, we can use this formula, the one that I was telling you. Yeah, so I like skip one step, but yes. Now we have the final, the initial, and the time, right? So basically we can get the maximum, the height. It's going to be 1/2 of what the final velocity when we
0.
are in Y, 0, right?
Yes.
Plus what's the initial velocity? We just calculated that it was 16.38, right?
Yes.
Times the time that we just calculated that it was 1.67, right?
Yes.
So basically, if you put this in your calculator, you are going to get
13.78.
perfect
68.
13.68 watt
Yes. Meters.
meters. Perfect. Okay, that's really good. But now let's think a little bit about the parabolic movement, right?
Yes.
If you remember, when we are at our maximum height, right? We are at half of the parabola, right?
Yes.
And we said that the same time that it takes to go up is the same time that it takes to go down, right?
Yes.
So basically, this is just half of the time of the complete parabola.
Okay.
what do you imagine that we have to do in order to get the complete time?
Multiply it by 2.
Multiply by 2, perfect. So the total time, right? Total, right? It's going to be 2 times what?
1.67.
Perfect. So in that case, we are going to get the total time that, what is it?
It's 3.34.
Perfect. Thank you. Okay, seconds, right? Okay.
Yes.
Now we have the time. And what else do we have? Okay, let me see. For getting the range, okay, we have the time and we have the original velocity, right? The Vx. That is what
Yes.
we want. So basically, we just have to do the algebra, despejar, right? And we are going to get that the range, right? Is equal to, okay, maybe another color. Vx multiplied by delta time. And Vx is equal to?
Vx is 11.47.
Perfect. And what is our time?
3.34.
3.34. So can you please do it?
Yes. 38.31.
Perfect. So we get 38.31. What unit? The range.
Meters.
Meters. Perfect. Then, well,
But I have
yeah,
a question.
yeah.
In the first problem, why didn't we multiply the time times 2?
Okay. Because, okay, let me see like in the figure. Okay, here, this is the perfect. Because if you see, this is like half of the parabola, right? So basically, we ignore this part because that
Okay.
part like never happened. When we are talking
Okay.
about horizontal launch, we start from here. We don't
Okay.
start from here.
Okay.
That's why we just take half of the parabola, right? When we are
Okay.
talking about parabolic, we start from here. So in here, we are going to take both parts of the parabola, right? Like the whole parabola.
Yes.
Basically, it's because of that.
So only in parabolic launches, you double the time.
Yes, if they ask you for the reach, right? Just for the reach. Because, well, like for your classmates, because I teach them like maybe more deep. I teach them, for example, that for getting the Vx, right? In any time, it's basically the V0x multiplied by the time of flight. How do you get the time of flight? Well, this is like above the, I think that the level that they teach you, well, at least the exam that they put, right? In here. But for example, the time of flight, right? You get it most of the time from this formula. This one, right?
Yes.
Okay. Now you're going to see, oh, you still don't have like access to Canvas, right?
Yes. No.
Okay, well, because I left them homework. Like if you go tomorrow, I'm going to solve some of the problems in the class, right?
Okay.
Because generally I put like homeworks above the level of the exams, right? In order that you study really hard and you get like, a really good grades, right? Okay, but well, basically this is a square, right? Okay.
Yes.
If you remember from mathematics, the quadratic equation, it has this formula, right? Ax squared plus bx plus c, right?
Yes.
Okay. If you remember, okay, a is the one that is multiplying our unknown square, right? B is the constant that is multiplying our unknown to the 1 power, right?
Mm-hmm.
And C basically just the constant that is not multiplying any x, right?
Yes.
Okay, basically, well, the complete formula for this one will be H equals H0 plus B0t plus 1/2 GT squared, right?
Mm-hmm.
Okay, so let's see like the equivalencies, because also this is, both of them are quadratic equations, right?
Yes.
The equivalency, okay, A is the one that is multiplying our unknown square, right?
Mm-hmm.
In here, this is our unknown square, the time, right?
Yes.
What is multiplying the time square?
G. One half G.
1/2 G, perfect. So basically, our A is 1/2 G, right?
Yes.
Okay, our B. The B is the one that is multiplying our unknown to the 1. Basically, in here, this is T, right?
Yes.
What is multiplying our T?
Original velocity.
Perfect, original velocity, initial velocity, right? This is B, right?
Mm-hmm.
Perfect. And C. C, well, basically, if you remember for applying something that is called, if you remember, what is the general formula? Do you remember like the general formula for solving quadratic equations? Okay, let me maybe.
It's the one that's negative B plus minus
Mhm.
the square root of B squared minus 4AC divided by 2A.
Perfect. The general formula. Well, the square root of this. Don't forget it.
Mhm.
Okay. This one is going to give us two values, right?
Yes.
That's why the plus minus. Okay. Basically, for doing this general formula, we have to equal 0, right? This has
Yes.
to be of this shape. Okay.
Mhm.
So basically, what do you think that is going to be our C? It's going to be
Mm,
H0 minus H, right? We have to pass this one to this side. And
Yes.
if this is adding, this will pass subtracting, right?
Yes.
So basically, okay, we get these three, right? And like for getting like any value, because you can get the x position in any value. Like you don't have to limit to this one, right? You can get the x in here, you can get the x in here, in whatever position you want, right?
Mhm.
This is really useful because, for example, I don't know, like for sending missiles, right? Or I don't know, like whatever, like a shot or something. You can say, okay, at this time, in which position is going to be this projectile, right?
Mhm.
In which x, y position. You can get it really easy. For example, the x position, if you remember the formula, well, not just remember, it's in here, right? This is the
Mhm.
formula. The V0x, we get it from the beginning because it's just calculating the magnitude, right?
Yes.
This one. But the time of flight, it depends, right? On this stuff, right?
Yes.
If you want to know the x position at any height, like if you want to know, for example, I don't know, let's say this height, right?
Mhm.
Let's say this height is 12 meters, sorry, 12 meters. You
Mhm.
just input these 12 meters in here, right? The H0,
Yes.
you take it maybe a 0, like that, right? And
Mhm.
with that, using the general formula, you are going to get two times of fright. Why do you get two times of fright? Because if you see these two positions, right,
Yes.
are equivalent in Y. They have the same height, right?
Yes.
H1 and H2, they are equal. Basically, they will have time 1 and time 2, right? They are
Mhm.
going to be different, the times, but the heights are going to be
The
the
same.
same. That's why we get two values. we get one value that is before the parabola, and we get a second value that is after the half of the parabola, right?
Yes.
Okay, basically, that's why we can solve, well, we solve this general formula, and we are going to get time 1 or times 2.
Yes.
And now, like, you can decide, okay, maybe I want the first time. If you do that, right? Okay, sorry, this was a mistake. This is no x. This is x, right? Okay, x, right?
Yes.
Okay, and we depend of time, like function of time. Okay, in here, we had this from the beginning, and we calculated this from the general formula. So we input any of these two values, and will give us, okay, this x position, right? For this first point, and okay, a second. Sorry, it wasn't here. Okay, a second x, right? We are going to get this x2, this x1, right? Yeah, basically, like, you don't have to limit to get the range. Like, basically, in high school physics, that's the typical problem that they put. But in reality, with the same formulas, you can get any value, right? You can get the x in any position of the parabola. Kind of the same like the equivalent. If they give you an x, right, you can get the height in any point. Just like in substituting this formula, right? And getting the time of flight, and then the time of flight, you substitute it in the same formula, right?
Yes.
And you get the height. So, like, if they give you x, you can get y. If they give you y, you can get x, right?
Yes.
Okay. And basically, that's like, you don't have to limit yourself. Like, tomorrow you are going to see, like, we don't have time right now, but tomorrow I'm going to explain a problem that is more interesting. That basically, let me, like, for you to give you like a preview. Okay, for example, you have a gun, right?
Yes.
And you know that this gun, for example, shoots at 100 meters per second, right?
Yes.
And you want to hit exactly. Okay, a point, right? Like, I don't know, you want to hit exactly this coordinate, right? That is an x, y coordinate. So, for example, you want to shoot something that is 100 meters horizontal from you, right? And it's, I don't know, like a height of 20 meters, right?
Yes.
We are going to see tomorrow that there is a formula that you can see it even in Wikipedia. It's like a kind of hard formula, but like, you don't have to learn it. You just have to know how to input the value, right? There is a formula that it will tell you which angle you have to shoot that gun in order to hit exactly that point, right? Well, that's really useful because that's something that you can use like a lot in, like, well, like in real life, you are like engineering and want to, for example, a projectile, right? You have like a gun and you say, okay, I want to shoot exactly that point, right? With these calculations, you can know, okay, I have this gun that I know that it fires at 100 meters per second. So I know, like, okay, with this angle, I will exactly shoot that point, right?
Yes.
So yeah, basically we're going to do that because that's like part of the homework. Yeah, generally I put like in the homework, like, problems harder than the ones that you get in the exams, you know, that you get good, but still, like, well, you have to upload it. So, okay. But yeah, tomorrow we are going to see like 3 problems like of this level, like are a little bit above the level of the exam. But yeah,
Okay, so tomorrow what we're seeing will not come in the exam.
no.
Okay.
No, like the thing that we saw right now is like the perfect for the exam.
Okay.
No, like the ones that we are going to see tomorrow are above the level.
Okay.
It's for the homework because it's the homework. Like, basically, I'm going to solve the homework. Yeah.
Okay. Yes.
Okay. Well, good. Okay.